Well, simple interest is computed on the investment amount, the original investment amount or principal only, okay? If we know this to be the input, we know an interest rate expressed as a percent, we know the duration of the investment, multiplying the three quantities will yield the interest earned by that investment amount. So this is the formula for the calculation of simple interest. But we need to make something happen here. The interest rate is usually given as an annual percent rate, while the duration of the investment is usually given in whatever time units. So we need to make sure that the interest rate and time correspond to the same units. Example, if $8,000 is invested at 6% simple annual interest, how much interest is earned after 3 months? Let's identify our terms in this simple interest calculation situation. First, we talk about the principal, that is the investment amount is this. What about the interest rate? Okay, 6% annual interest. Okay, we know the annual interest. Then the duration of the investment, 3 months. So either we keep an annual interest rate and express the duration in years, or we keep the same units for the duration of the investment and try to convert this annual interest rate to the same time units of the duration of the investment. For example, if we do the latter choice, then the yearly rate of 6% we could transform into a monthly rate by simply dividing the yearly rate by 12, yielding 0.5% of monthly interest. Okay, using this modified rate, the duration of the investment, and the principal, we can input these values in the formula. The interest earned would be the product of 8,000 times the interest rate expressed as a percent, that is 0.5 over 100, times the duration of the investment in months. Notice that this is months, the duration of the investment, and this factor here, the interest rate, is also a monthly rate. If you prefer, you can work everything in an annual rate and a duration in years. You could always choose what represents a simpler and easier calculation. Okay, if you resolve, you get the answer, $120 is the interest earned. So let's see a couple of examples of questions where the simple interest formula must be used. Let's try question 1. It says a total of $20,000 was invested for 1 year. Part of this amount earned simple annual interest at the rate of X% per year. And the rest earned simple annual interest at the rate of Y% per year. If the total interest earned by the $20,000 for that year was $2,720, what's the value of X? Statement 1 says 4 times X equals 3 times Y. Statement 2 says the ratio of the amount that earned the interest at the rate of X% per year to the amount that earned the interest at the rate of Y% per year was 3 to 2. What would be the first step in our approach to the solution? Well, identify the question. The question is just this part. What's the value of X? Okay, interesting. What is X according to the information prior to the question? X is a percent, and it is an interest rate that corresponds to one operation of investment to simple interest, that part of the original $20,000 was applied. So we know that the $20,000 were divided in two parts. They mention a first part of the amount that was related to this interest rate, and there is another part of the $20,000 called the rest, which was related or was applied a different interest percent rate, interest rate of Y%. So this rest has to do with this other rate. So how do X and Y relate to each other, and how do X relate to $20,000 and to the two parts of these two $20,000? Well, let's consider defining here a variable in order to make easy to identify this relationship among all variables. If part of the amount, the part that was set to earn interest at the rate of X% yearly, we call P. And the rest, well, the rest we simply call 20,000 minus or take away P, because the sum of the two is $20,000. So according to the formula of simple interest, the interest earned by the first part of the $20,000 would be that amount of money multiplied by the annual interest rate of X%, X over 100, multiplied by the duration of the investment, which was 1 year. Here it mentions the duration, such duration of the investment. So we would have to multiply this by 1. So this is the interest earned by the P dollars. And what is the interest earned by the other part of the $20,000? Well, the other part of the $20,000 would have to be $20,000 take away P. Okay, so that's the second amount. So $20,000 take away P would be invested to Y% for 1 year also. So this product represents the interest earned by the second part of the $20,000. So we might say that the sum of these two expressions represents the total interest earned by the $20,000. According to the information prior to the question, says that total interest earned was this number. So this has to be the sum of the two expressions, right? The total interest earned. So here we have an interesting equation. Let's here highlight this. It's an equation that expresses the complete relationship of X to other quantities mentioned in this question. So you see how X relates to Y and relates to P in a unique equation. In other words, if you want to know the value of X, you need to know P and Y. So statement 1, if we evaluate looking at the equation above, allows you out of this proportion, you know that X over Y equals 3 to 4. You have a way to substitute the two variables X and Y in terms of just one. So you can reduce one variable using this information, but what about P? P remains an unknown, cannot be found. So even if you can reduce Y by substituting Y in terms of X, you still have P, and you have no other way to get rid of P. So if you don't know P, you don't know X in a unique manner. So it means that X cannot be determined either. Statement 1, not sufficient. What about statement 2? Well, statement 2 says that there is a ratio between two amounts. The P dollars, that is the amount that earn interest at the rate of X% per year, divided by the amount that earn the interest at the rate of Y%, that is 20,000, take away P. The ratio of these two is 3/2. Obviously, from this proportion, I can obtain the value of P. Yes. So I can substitute P in the equation above, but I would be reducing the original equation to an equation with variables X and Y. Since I don't know what relationship exists between X and Y, right? I have no way to write one in terms of the other because I don't know any other relationship. Then you have a single equation with two variables that may represent decimals. Why not? So clearly, we don't have a unique answer for X. So not sufficient. Okay, statement 2 alone is not sufficient. But then when you consider the information of statements 1 and 2 together, it becomes clear that we can find a unique value for each of the three variables. Okay, I have the equation above, equation number 1. This is our equation number 2, and this is our equation number 3. Three different equations, three different variables. I can solve each of the variables in a unique manner. So you can find P, you can find X, you can find Y in a unique way. Sufficient, and the correct answer would be option C. Both statements together are sufficient, but neither statement alone is sufficient. Let's see another example. If $4,000 invested for 1 year at Y% simple annual interest yields $480, what amount must be invested at X% simple annual interest for 1 year to yield twice the number of dollars? So if we focus our attention on the information in this first line, the information prior to the question, we can notice that this describes an operation of simple interest calculation. We have the investment amount or the principal multiplied by the interest rate, the yearly rate of Y%, and the duration of the investment in years is 1 year. This product means the interest earned, which is 480. So from this equation, I can reduce the value of Y. So 4 times Y equals 48. Y then is 12%. Okay, this is interesting. The question says, what amount must be invested at X% simple annual interest for 1 year to yield twice the number of dollars? But the expression twice the number of dollars, this expression here, makes reference to the number of dollars mentioned in the information prior to the question. In other words, this means 2 times $480. So let's interpret the question in terms of variables. For example, what amount, our unknown, we can call it A, okay? This amount of money is an investment amount, and it will be invested at the annual interest rate of X%. So if we multiply this by X% and for the duration of 1 year, this expression is the interest earned by that amount of money. And if this interest will be twice the number of dollars mentioned above, it would be this. We have an equality with letters X and A, meaning that one depends on the other and vice versa. So if I want to know the value of A, I need to know the value of X. But statement 1 that says for x equals 5y can yield the value of x. X would be 5 times 12 divided by 4. In other words, 15%. So if we substitute 15 in the equation above, we can isolate the value of A. A would be a unique number, a unique amount. So statement 1 sufficient. Statement 2, likewise, gives us another expression in terms of x and y that connects x and y. So from this, we also know that y would be what? 12% plus 3x would be 15%. Again, we have a unique value for A. So statement 2 alone is also sufficient. Correct answer choice, each statement alone is sufficient. Well, we've seen some examples of simple interest. Let's now consider the formula for the calculation of compound interest. Compound interest is computed on the principal amount as well as on any interest already earned. So it's an accumulative interest calculation. The interest of the first period will adapt with the principal to be used as the basis for the interest of the second period. Then the interest of the second period will be added to the previous amount. Then this will be used as the basis for the calculation of the interest in the third period and so on. So finding what is this money that a certain investment amount yields when being applied a compound interest rate, we can use this exponential formula where the total balance, that is the total money in your investment account, which is made of two parts, the original investment amount, the principal, plus the accumulated interest. That is what we understand when we talk about the total balance. So this total balance would be the original investment amount times 1 plus the interest rate raised to an exponent which is equivalent to the duration of the investment. How can we work with these calculations considering that in the GMAT, we are given interest rates that are not always, referred to the same period when the interest is accumulated. We are given normally an annual rate, but then a frequency of interest accumulation indicated by the phrase compounded or accumulated quarterly, monthly, semi-annually, or annually perhaps. Well, only those options. And also, the duration of the investment can be given in any time units whatsoever. So having different formulas that combine all possible cases for frequencies of interest accumulation and time units for the duration of the investment would be very complex. Rather, we can use a simple rule. Try to use a modified rate and express the duration of the investment as a number of periods where the interest is generated and compounded. And the modified rate would also correspond to that frequency or period when the interest is compounded. For example, if they tell you to calculate what is the total balance if you set $1,000 to earn interest at an annual interest rate of 12% compounded quarterly for 2 years, we would use our input of an annual 12% rate to calculate a modified rate that corresponds to this quarterly period of accumulation of interest. So since a year has 4 quarters, you would divide this 12 by 4. Dividing it by 4 yields 3%. And the duration of the investment, we can also express in a number of quarters. So you see a quarterly rate and a duration in quarters. So that is to say that the operation that we are to do here in this example one would be 1,000, the principal amount, times 1 plus this modified rate of 3% quarterly up to an exponent, which is the duration of the investment in quarters. So 2 years represents 8 quarters. We place this value 8 here as the exponent, the duration of the investment in periods of accumulation of interest. So the result of this expression is the total balance. The second example, imagine that you have also $1,000 placed to earn interest at an annual rate of 24% compounded monthly for 1 semester. So do the same. Since the frequency is monthly, divide 24 by 12 to obtain a monthly rate. And then the duration in semester divided by 6, right? Or divided in months. You have months here. So the expression for the second example would be the total balance 1,000 times 1 plus 2% up to 6. In the third example, the same $1,000 set to earn interest at an annual rate of 16%, but compounded semi-annually for 1 year. Okay, so the modified rate corresponding to 1 semester is 8%. You just divide 16 by 2. And the year of the duration, you can express in 2 semesters, 2 periods of half year each. So using this, your calculation this time would be the principal times 1 plus the modified rate of 8% up to exponent 2. And that's it. So that's a strategy you can use to work with a compound interest formula in GMAT questions. Let's see examples now. Question 3 says, Laura deposited $10,000 to open a new savings account that earned 2% annual interest. Let's notice here the annual interest rate compounded semi-annually. Okay, the frequency of interest accumulation. If there were no other transactions in the account, what was the amount of money in Laura's account 1 year after the account was opened? So we have our interest rate, we have the frequency of interest accumulation, we have our principal, and the duration of the investment is 1 year. Okay, so using this, we can generate all the terms we need in the formula. First, let's calculate our modified rate. What's our modified rate? Well, if we have an annual rate, but the interest accumulation happens semi-annually, we need a semi-annual rate. Okay, in this case, semi-annual rate means dividing the yearly rate or annual rate 2 over 100 by 2, because each year has 2 semesters. So this gives us 1 over 100 or 1%. Now, what about the duration of the investment in terms of periods when the interest is accumulated and compounded? Okay, if we have 1 year, 1 year is equivalent to 2 semesters or 2 half years. So using this and this, we will calculate the total balance in Laura's account by using the compound interest formula. Okay, so the total balance equals 10,000 multiplied by 1 plus the modified rate of 1%. This is a semi-annual interest rate up to the duration of the investment expressed in numbers of semesters, 2. Okay, we can use the formula to open up faster the square of a binomial. So you have the square of the first term plus twice the product of the two plus the square of the second term. So we get this trinomial, which multiplied by 10,000 yields 10,000 plus 200 plus 1. So the correct answer choice must be option 4. Let's see another example. Question 4. An investment of $1,000 was made in a certain account and earned interest that was compounded annually. The annual interest rate was fixed for the duration of the investment, and after 6 years, the $1,000 increased to $4,000 by earning interest. In how many years after the initial investment was made would the $1,000 have increased to $16,000 by earning interest at that rate? Well, at the beginning, we are given a situation of compound interest calculation. We have a principal of $1,000. We have an interest rate which is unknown, but is an annual interest rate. Let's call it X%. And the duration of the investment was 6 years. So since we have the 3 elements, we can see that the multiplication of the 3, that is 1,000 times 1 plus the interest rate up to the duration of the investment should yield the total balance, which is mentioned to be $4,000. Then we are requested to find how many years, let's say a number of years n, should pass for the $1,000 to have increased to $16,000 by earning interest at the same rate. So in another situation, we have $1,000 times 1 plus the same annual interest of X% up to a duration of the investment which we want to determine, n years, in order that the total balance after these n years have passed equals $16,000. So it's basically determining n, knowing that we have this information about x. Okay, first of all, in these two equalities, we can get rid of the thousands, simplify the expression. The first equation would be 1 plus x over 100 up to 6 equals 4. And we can use this information in order to determine the value of n. Instead of isolating x and replacing in the second equation, we can use the expression as a whole here, this power with a 6th exponent, to calculate n. We can use the properties of powers and exponents to express this power here, 1 plus x over 100 up to n, as a power of a power, in which the original base is this power, and we raise this power to a certain exponent n over 6, which you might guess after multiplying the two exponents, what you get is the same exponent n. So we can say that the two expressions are equivalent, but we know that the value of what is in the square brackets is 4. So this equals 4 up to n over 6. While on the right side of the equality, we have 16, which we can represent as the square of 4. So there is another property that says that if we have two powers of the same exponent, sorry, of the same base, having the same value, that is the two powers are equal, then the two exponents must be the same. So n over 6 must be 2 and n should be 12. And the answer to the question is option B. Now let's see question 5. Question 5 says, Martin bought a 6-month $10,000 certificate of deposit that paid interest at an annual rate of 16% compounded quarterly. What was the total amount of interest paid on this certificate at maturity? According to the question, the principal should be the $10,000, right, that Martin paid for this certificate of deposit. The duration of the investment, the time is 6 months. There is an interest rate of 16%, but it's an annual rate. And the frequency of accumulation of interest is quarterly. So considering the frequency and the annual rate, we can determine a modified rate. A modified rate that corresponds with the period when interest is compounded, that is a quarter. So by dividing 16% by 4, because each year has 4 quarters, you have 4% quarterly. And then the duration of the investment, we can express also in quarters. So that would be 2 quarters, 6 months. So this means that using this information, we can calculate the total balance, which we know to be the sum of the principal, the initial investment amount, plus all the interest earned. This would be equal to the principal, 10,000, multiplied by 1 plus the modified rate of 4% up to the duration in quarters. This duration goes here as number 2. So now we can use the same rule to expand the square of this binomial. We have 10,000 that multiplies the trinomial 1 plus 8 over 100 plus 16 over 10,000. Obviously, this yields 3 terms, this multiplication. And doing an identification of terms with the left side of the equality, this goes away, and the interest is $816. Corresponds to option C. Well, that's it. The last example and the end of the lesson today. See you on the next class.